6.8, Graphing Radical Functions. One thing about this section, it is very similar to your Chapter 4 and Chapter 5 from last semester, meaning that these transformations are the same that you saw for different parent functions. So today we're going to focus on mainly this one and cubic. We focus on square and cubic. So one thing when we're looking at these is that if there's a opposite out here that makes it reflect over the x-axis. So if you're multiplying by a negative, reflect over the x-axis. If the number out in front is greater than 1, and that is the same thing as less than -1. So the negative flips it, the actual number then will either, if it's greater than 1, it will be a stretch. If it is less than 1, or in between 0 and 1, it will be a shrink. So shrink is between 0 and 1, stretch greater than 1. And then this on the inside, so underneath whatever the parent function is, underneath that root, this moves it left and right, this is always opposite. Because in the original, as you can see right here, it says minus. So if this says minus, it actually moves to the right. If it says plus, it actually moves to the left. This number out here is going to move it left or up and down. That's the same thing for cubic, square root and cubic. Now this point, this HK, that's the point we're always going to be looking at. So today we're going to be graphing these, and when you're graphing these, you're going to be not using a quadratic. And by quadratic, I mean a graphing calculator. You should be able to do this in your head. So one thing, I like to see either 3 points more if you can, but for sure 3 points on these. So for this first one, we're going to be graphing square root of x minus 2. So this is a transformation. So that right there is going to move it down 2. Now if you want to, you can make a table. Now one thing about doing this root and knowing how the HK, if it moved left or right or up or down. Since I did not move left or right at all, that would be 0. And I moved down 2, that would be -2. Now you can always evaluate that. If you put 0 into this equation, the square root of 0 is 0. Subtract 2 is 0, -2, that's this point. Now because of this root, we cannot do anything less than 0 because that would give us imaginary numbers. So now once we know this point, we're going to be graphing numbers on the right hand side of it. So +1, and I'm going to pick +4 and +9. Now I'm thinking, why did you choose these numbers? Well, if you look at these 3 numbers, actually 4, these 4 numbers are easy to do in my head. Why? Because I'm taking the square root of them. If I need to take the square root, I want to make sure it's something that I can easily do in my head. So if I do 1 squared is, or the square root of 1 is 1, minus 2 would give me -1. The square root of 4 is 2, 2 minus 2 is 0. Square root of 9 is 3, 3 minus 2 is 1. And I plot those points. So these are our points, and this is going to keep on going and moving to the right. The arrow is going to keep on going on forever. My domain, so when I'm looking at this, you're always focusing, domain is left and right. So when I'm looking at this, if I look at this, how far left did I go? Well, this is where I stop right here. I'm not going any farther. But then on the right, I go into infinity. So that means x can start here and then go on forever. So x has to be greater than, this value here for x is 0. So this domain would be x is greater than or equal to 0. So it can be 0, but not anything else. Then my range is, do I move how far down I can go? So this is how far down. So if I look at my graph, I'm not anywhere farther here. And if I look above it, it's going on forever. It will keep on going on and on and on. So this is my furthest down I can go. So if I look at this, y is greater than this point, and y right here at this point is at -2. So y is greater than or equal to -2. I want you to pause the video and do the next one by yourself. For these next problems, I'm going to try to not talk as much. So first when I'm looking at this, it's underneath my root, so that means it's going to be left and right. So this case is going to move to the left because it's positive. It's going to move left 4. So now when I'm doing this, by making my table, I moved left 4, and I did not move up and down, so it would be 0. Now, one thing when you're putting this in your calculator, you want to figure out what numbers to use so that you can do an easy square root. So the next easy square root, besides 0, because negative 4 would give me a 0, the next easiest square root would be a positive 1. So if I put in negative 3, I would get a positive 1, square root of positive 1 out. If I put 0 in, 0 plus 4 would give me 4, and I can take the square root of 4 because that would give me 2 out. The next positive root would be 9, so I have to think what number should I plug in. So if I plugged 5 in, 5 plus 4 is 9, the square root of 9 is 3. Plot those points. Here we go, and graph it. So I am looking at my domain. Domain is how far left to how far right you go. So how far left, I don't move any farther than this. This is the farthest I go, and then I move to the positive. I go positive forever. So my domain would be x is greater than or equal to, and that point where x is negative 4. And my range is how far down you go. So this is how, oopsie daisies. This is how far down I go, and then it looks like I'm going to be going up. I'm going up forever. So y is greater than or equal, the furthest down I go would be 0. If you haven't noticed, these numbers are that same number right here. That should be a hint. Pause and try to do the second one by yourself. Again, just to save time on me writing. Now for A, I'm going to look at my transformations. So first, the negative, that's going to reflect over the x-axis. This 1/2, this is less than, so I don't care about the negative. I'm just looking at the 1/2. This is going to shrink it. This one is going to move it to the right 2, because this one's always opposite. Right 2, and this is going to move up 1. So this is where I'm going to focus first. Right 2, up 1. So I make my table. Right 2, or 3, sorry. Right 3, and then up 1. So now again, when I'm picking my numbers, I want to pick numbers that will make it easiest to take the square root in my head. So I know 4 minus 3 would give me 1. The square root of 1 is 1. 1 times negative 1/2 is negative 1/2 plus 1 would give me a positive 1/2. My next number would be 4. What number should I plug in? So to make that 4, well, 7 minus 3 would give me 4, so that would give me a 2. 2 times negative 1/2 would give me negative 1 plus 1 would give me 0. And then my next number, I actually can't fit any more numbers on here. The next number I would want to try to get at would be 9. Well, I would have to plug 12 into the equation, and I don't have that on my graph. So I plot my points and graph it. As you can see, because of the 1/2, it shrinks. Because of the negative, it flipped. So my domain here is going to be x. When I look at my x values, this is the furthest, the smallest x gets, and goes on forever. So x is going to be greater than or equal to 3. My y, look at my y values. So here's where I start, and then it's going down. Now this is different. It's going down, so if it's going down, y is less than or equal to, and this value that y is at would be a positive 1. So I want you to try to do B by yourself. So now we're doing cubic. I'm actually going to do B because it's a little harder. One thing I noticed about B, it might be easier and more visually appealing if you rewrite the problem that we have y is equal to a negative 1/2 and then a cubic x minus 2 plus 3 here. The reason why I would say to do that is because, again, this is the point that will help us when graphing. Now, a little bit different because it's cubic. Now we don't have as many restrictions on us because we can take the cubic root of a negative. We can't take a cubic root of a positive. That's why we started with that point on top for the other ones. But now, since we can take a cubic root of a negative, this is going to move it right 2 and up 3. So now I put that point in the middle. So I put the point in the middle because I can take the cubic root of negative numbers. So I can also pick 1 and 3. If I plug 1 into my equation, I would get a negative 1. Cubic root of negative 1 is negative 1 times negative 1/2 would give me a positive 1/2 plus 3, so I get 3.5. Again, what I'm verbally telling you is the mental math that you should be trying to do in your head. If I plug 3 into my equation, 3 minus 2 is 1. The cubic root of 1 is 1. 1 times negative 1/2. Negative 1/2 plus 3 would give me 2.5. Now I can also plug in negative 6 and 10. Why do those two work? If I plug negative 6 in, I can do negative 6 minus 2, which would give me a negative 8. Cubic root of negative 8 is negative 2. Negative 2 times negative 1/2 is positive 1 plus 3 would give me 4. And 10. 10 minus 2 is 8. Cubic root of 8 is 2. 2 times negative 1/2 is negative 1 plus 3 is 2. And I plot these points. Now it's kind of hard because this one did shrink, and it shrank because of the 1/2. Now the point here, this 2, 3, that's kind of the point where it should help you kind of graph this. If I take that point, kind of looks like a whoosh over here, and then it's a little whoosh over here. So now if I'm looking at this, my domain, how far left do I go? I go left forever. How far right do I go? I go on forever. Forever. All real numbers. My range, how far down do I go? Again, this, oopsies, would be going on forever and ever and ever and ever. How far up do I go? It goes on forever and ever and ever. Forever. Whoops, I forgot my extra line. So that would be all real numbers for both of those. Pause and do question number 4. And the last two, I'm going to do B also again today on this one. So you have to try to rewrite this so it's easier. Now, one thing you should always do with these problems, you should look to see what factor do these have in common. And if there's a nice factor. What makes it a nice factor compared to this one or this one? Well, a nice factor would be something that I can easily take the square root of in here, or the cubic root here. So when I'm looking at, I'm going to do B. So when I'm looking at this, I can factor out of that. So I'm still going to have my cubic root. I can take out an 8, leaving me with x plus 4, and I still have this minus 2 out here. The reason why I do that is because I can split up multiplication. I can take the cubic root of 8, and then I would have the cubic root of x plus 4. I would still have that minus 2. The cubic root of 8 is 2, so I can simplify that to 2. I'm still going to have that cubic root of x plus 4, and I'm still going to have to subtract 2. Now, this is asking you to describe the graph. So what is the transformation? Basically, that's what it's asking you to do right here. So I have a stretch of 2. That's this right here. I would have moving left 4. That's this right here. And finally, I would have down 2. And that's because of this right here. So that would be B. So pause. Or actually, just do A. You don't even have to pause it because we're done. Finish. I don't know any other words. I don't know any languages. I guess I have to learn some new languages. Have a great, wonderful, fantastic time of your life.